Well, welcome back to chapter 15, and now we are going to talk about those outer planets, the gas giants. So we'll start with another one of our National Geographic videos, which has lots of interesting information about the first of the gas giants that we're going to talk about. So far, we've looked at the inner planets, Mercury, Venus, Earth, and Mars. And of course, between Mars and the gas giants, which separates the inner planets from the outer planets of the gas giants, is an asteroid belt. And the first planet after the asteroid belt is Jupiter. So let's learn a little bit more about Jupiter.
Born from primordial stardust 4.5 billion years ago, Jupiter was the solar system's first planet. And much like its namesake, the king of the ancient Roman gods, Jupiter was destined for greatness. Jupiter is the fifth planet from the Sun and the largest planet in the solar system. At approximately 11 Earths wide, Jupiter has twice the amount of mass as the other planets put together. But unlike Earth and the three other terrestrial worlds, Jupiter has no solid surface. It may not even have a traditionally solid core. Rather, this giant planet may have a dense liquid center surrounded by a worldwide ocean of hydrogen and helium gases. Jupiter's gaseous composition can be observed in its atmosphere. About 44 miles thick, the atmosphere is a canvas of stripes and storms churning across the giant planet. Their colors range between shades of whites, yellows, browns, and reds, all caused by the different chemical makeup of each area. Probably the most iconic feature of Jupiter is a crimson-brown storm that's been raging for over 300 years, the Great Red Spot. It's a giant swirling collection of clouds with wind speeds of up to 400 miles per hour, at least 2.5 times faster than Category 5 hurricanes. Floating hundreds of miles above the storms of Jupiter are about 79 moons, most of the 8 known planets. The 4 largest moons were discovered by Galileo in 1610. Called the Galilean satellites, they include Io, the most volcanically active celestial body in the solar system, Ganymede, the solar system's largest moon, even larger than the planet Mercury, and Callisto and Europa, which, along with Ganymede, may contain oceans of liquid water underneath their crusts. Jupiter's large collection of moons is only made possible by the planet's massive size and gravitational pull, the strongest of all the planets in the solar system. This incredible gravity also influenced the sizes of the 7 other planets. During the solar system's earliest days, Jupiter, being the first planet to form, attracted and destroyed space debris that would have helped the other planets grow in size. Today, that force may serve as a shield by attracting comets and asteroids onto Jupiter's own surface, preventing them from crashing onto inner planets like Earth. Apart from the Sun, Jupiter has become the dominant figure in the solar system, thereby earning its place at the top of the planetary heap as king.
So Jupiter, which is our largest planet from or in our solar system, it's 5 astronomical units from the sun. So it's 5 times further away than the Earth is from the sun. And it's about 318 times greater than the Earth's mass. It's made of mostly hydrogen and helium with an iron silicate core. So you can see in the little image below. So that hydrogen and helium form that gas layer. And of course, there is the liquid hydrogen in the core, and then the atmosphere, of course. And in addition to the hydrogen and helium, there's also ammonia clouds there as well. The iron silicate core sits at the center of Jupiter, and this core is 10 to 15 times the mass of the Earth. After Jupiter is Saturn, but one of the key features that was mentioned here in the video was the giant red spot of Jupiter. If you're able to view Jupiter in a telescope, depending on the magnification, you should be able to see that little red spot. It looks like a little red spot, but we learned today that it is a very large storm that's been going on for several hundred years. So in addition to having mostly hydrogen and helium, some ammonia and water, the Jupiter also has about 69 satellites that's orbiting. And these satellites are Jupiter's moons. They're called Galileo satellites. And we learned of the different names of some of the larger satellites. We also looked at the fact that some of these satellites are, some of these moons are volcanic, and maybe one of them would be the most volcanic body in the solar system. And then you have others that may have water under their crust. So that's a larger picture of Jupiter showing the hydrogen and rock and ice core surrounded by that giant storm. And here are those more popular of Jupiter's satellites or moons: Europa, Io, Callisto, and Ganymede. After Jupiter is the planet Saturn, most notably known for and very popular for having the rings that's called the rings of Saturn around it. So before we go on to make some notes on Saturn, let's look at the National Geographic video on Saturn.
With its gold color and stunning rings, Saturn is quite a planetary gem. Saturn is the second largest of the 8 planets, and it is about 10 times as wide as Earth. Despite its size, Saturn is actually the lightest planet. It is predominantly made of the gases hydrogen and helium, and because of its particular gaseous composition, Saturn is the only planet in the solar system that's less dense than water. If the planet were placed on an enormous ocean, it would be able to float. Saturn's gaseous makeup also means that it has no true surface. At its center, the planet has a dense core of water, ice, and rocky material, but it has no actual landmass. Instead, it's mostly made of gases, liquids, and yellow ammonia crystals that swirl around the planet, creating golden clouds and storms. The largest storm on Saturn is at its north pole. It's over twice the size of Earth and shaped in a near-perfect hexagon. Each of the 6 sides is believed to be the result of jet streams, which all encircle a massive hurricane. Because of Saturn's inhospitable environment, the planet cannot support life, but some of its moons might. Saturn has more than 50 confirmed moons, and each varies in size and terrain. Enceladus, one of Saturn's smallest moons, is covered in ice and only about as wide as the state of Pennsylvania. Titan, Saturn's largest moon, is nearly as wide as Canada. Titan is also the only moon in the solar system with clouds and a dense atmosphere. Both Titan and Enceladus have underground oceans that would make them potentially capable of sustaining life. Saturn's moons may also play a role in shaping the planet's signature feature, its rings. Saturn's ring system is the largest and most complex in the entire solar system. The rings are made of icy and rocky remnants from comets, asteroids, and moons. The particles range in size from being as small as dust to as big as mountains. The ring system is divided into 7 groups of rings. Altogether, they are as wide as 4.5 Earths, but only about 2/3 of a mile thick. How the rings are able to stay on track and intact has to do with Saturn's smallest moons. Called shepherding moons, these tiny satellites orbit between the rings, and they seem to use their gravity to shape the ring material into circular paths. Saturn has fascinated scientists and amateur astronomers alike for thousands of years. The ancient Greeks and Romans, who named the planet after the god of agriculture, believed it was a star. It wasn't until the 17th century, after the telescope was invented, that scientists like Galileo Galilei, Christian Huygens, and Giovanni Cassini could take a much closer look. Only then was Saturn's planetary status discovered, and ultimately its many moons and brilliant rings. Because of its planet-like moons, lightweight composition, and dazzling ring system, Saturn continues to mesmerize us to this day.
So here we see the rings of Saturn, and of course stretching out to the location of some of Saturn's moons that we heard about in the video. Saturn is 9.5 astronomical units from the sun, and its density is 0.7 that of water. The density of water is 1 gram per cm cubed or 1 kilogram per meter cubed. So the density of Saturn is 0.7 grams per cm cubed or 0.7 kilograms per cubic meter. So it's not as dense as water, and as we learned, Saturn will be able to float on water. The rings of particles and more than 60 moons orbit Saturn, and Titan is the only moon of its big list of moons to have a substantial atmosphere. So these are some of the major moons of Saturn. Titan is the one that is large enough to have its own atmosphere, and many of the moons also consist of gas and also chunks of ice or layers of ice. Next in our list of gas giants is Neptune.
Along the dark edges of the solar system, it floats. Anchored by a star, but barely graced by its warmth, this traveler drifts alone, as deceptively calm and elusive as the deep blue sea. Neptune is the 8th planet from the Sun. At about 30 times the distance between our star and the Earth, or 30 astronomical units, Neptune is the most distant planet in our solar system. This distance creates the longest orbit of the 8 worlds, about 165 years, with the seasons lasting a little over 40 Earth years each. Being so far away from the heat and light of the Sun, Neptune is cold, dark, and icy. At its heart is a solid core about 1.5 times the size of Earth. Making up about 45% of the planet's mass, the core is made of water ice and silicate rock. The rest of the planet is believed to be a hot, pressurized ocean of water, methane, and ammonia ices surrounded by a layer of clouds. These clouds, predominantly made of hydrogen and helium, traces of methane, which give this ocean world its rich blue color. While the clouds create a cool, calm veneer from afar, up close they are whipped around by the most severe weather in the solar system. Winds on the planet reach speeds of over 1,200 miles per hour, nearly 5 times faster than the strongest winds recorded on Earth. In fact, the winds are so powerful that they break the sound barrier. Drifting high above this windy ice giant is a quiet ecosystem of rings and satellites. 6 rings encircle the planet, with some containing ring arcs, or clusters of dust particles in a ring. Also revolving around the planet are 14 known moons, with the largest called Triton. Named after the son of the ancient Greek sea god, Triton has ice volcanoes and may even contain a subsurface ocean. Much is left to be discovered about Neptune, its rings, and its moons. Only one spacecraft, Voyager 2, has visited these cosmic bodies, but future missions to this mysterious icy world would have even more stories to tell.
And I think we skipped before, between Saturn and Neptune, we have Uranus.
In ancient times, humans studied the night sky and discovered the worlds of Mercury, Venus, Mars, Jupiter, and Saturn. But beyond this realm of knowledge, another world shone brightly, just waiting to be discovered. Uranus is the 7th planet from the Sun. From a distance of about 20 astronomical units, or 20 times the distance between Earth and the Sun, Uranus orbits the star once every 84 Earth years, approximately the length of a human's entire life. This orbit causes each season of Uranus to last that much longer. Theoretically, a human living on Uranus would experience the 4 seasons only once, but each for about 21 years. Partially due to its distance from the Sun, Uranus boasts the coldest temperatures in the solar system. These icy temperatures, dropping as low as negative 370 degrees Fahrenheit, are largely influenced by the planet's composition. At about 4 Earths wide, Uranus has an Earth-sized core made of iron and magnesium silicate. The remainder, approximately 80% of Uranus, is a worldwide ocean of ices made of water, ammonia, and methane, the chemical behind the planet's cool blue color. This icy composition prevents Uranus from emitting much heat compared to other planets, making the blue world the solar system's coldest. In addition to its extreme temperatures and orbit, Uranus has a dramatic orientation. While the other 7 planets spin on their axes like tops, Uranus appears to roll along its equator. The planet is tilted at a near right angle, in which polar regions point toward and away from the Sun rather than upward and downward. This tilt, thought to be the result of Uranus's collision with at least one celestial body, has also affected the orientation of Uranus's 13 rings and 27 known moons. Unlike the rings and moons of other worlds, which orbit their home planets horizontally, those of Uranus orbit in a vertical orientation along the planet's tilted equator, much like a Ferris wheel. Uranus and its many unusual features were a mystery to the ancients, and the planet was actually thought to be a star. But in the late 18th century, astronomer William Herschel discovered that the celestial object was actually a new world. The scientific community debated over what the planet should be called, and eventually chose a name suggested by astronomer Johann Elert Bode. Bode believed that since Jupiter was the father of the gods, and Saturn was the father of Jupiter, then this new planet should be the father of Saturn, Cetus. But rather than following the tradition of using names from ancient Roman religion, Bode instead opted for Celus's ancient Greek equivalent, Uranos. Uranos, the ancient Greek god of the heavens, was then Latinized to be Uranus. To this day, Uranus is still the only planet that veered from tradition with an ancient Greek namesake, a status most fitting for a planet beyond convention.
So there we have the last two planets of our solar system, Uranus and Neptune. And they both consist of rings. They both consist of frozen water and methane, as well as gases. And they are both, Neptune orbits at a more vertical position than, so Uranus orbits in a more vertical position than Neptune. So while Uranus is about 19 to 20 astronomical units, Neptune sits at about 30 astronomical units away. So this is a distance away from the sun, 30 times as far as away from the sun as our Earth. So these are very, very cold planets, and they are the most outermost, and they both have similar structures and similar types of materials. Therefore, we have this sort of similar blue color associated with them. All right, so that is the end of our gas giants. We will move on to talk about the other types of bodies that exist in our solar system.